Alright, so today we're doing radicals again. First thing I want to talk about is how to simplify something like the cube root of 40. Do we know how to do that? What's that? Kind of. If there's nothing, is there any number out there we could take times itself 3 times to get to 40 without using decimals? No, there's not. So we're going to use a factor tree. Because I need something times itself 3 times. And nothing goes evenly into 40. So if we break 40 down into its primes, what goes into 40? What's one number that goes into 40? Okay, so we could use 4 and 10. We don't have to use 4 and 10, but we could. 4 breaks down into 2 and 2, so there's 2 primes. 10 breaks down into 2 and 5. So what I have underneath here now is I have 2 cubed times 5. That's the same thing as 40, right? 2 times 2 times 2 is 8, times 5 is 40. Okay, so if I take the cube root of 2 cubed, what am I going to get? 2. And I have 5 left over, so I have 2 cube root of 5. Okay, so that's how you break 40 down if you're looking for the cube root of 40. Now, let's expand on this a little bit. Let's go to this one. So if I want to take the square root of 50, x cubed to be the, not x cubed, but a cubed be to the 4th. So let's start with the square root of 50. Can we take the square root of 50 evenly? Is there anything times itself that you can get to 50? No. If you take 7 times 7, you get 49. 8 times 8 is 64, but there's nothing that gets us to 50. So I have to break down 50 with a factor tree. If this is a square root, what kind of, how many, of a particular number, how many do I need if it's a square root? I need 2, right? I need a pair. So 50, we can break that down into what? Okay, so we have 5 and 10. 5 is a prime. 10 breaks down into 2 times 5. There's more primes. So that would give me the square root of 2 times 5 squared. Now I need to break my a cubed down. I need pairs. So how's a cubed going to be broken down? Elizabeth? Okay, a squared times a. What about b to the 4th? B squared and b squared. And if this is even, what significance does that have? What's it mean if we're taking the even root of a number or a term? Elizabeth? Okay, so we need the absolute value of each variable. So if I try to take the square root of 2, can't really take the square root of 2 evenly. Square root of 5 squared is 5. Square root of a squared is a. Can't take the square root of a, so I have a 2 left over, I have an a left over. Square root of b squared is b. And the square root of this b squared is also b. And I still have the square root of 2a. Now I'm going to put my b's together and I'm going to add my absolute values into the problem. So I have 5, absolute value of a, absolute value of b squared, square root of 2a. If this is even, we use absolute value, and we don't use it if it's odd. Because if we're looking for squareds, can I possibly have a negative number if I'm squaring stuff? If I square negative 5, I'm going to get positive 25. If I square a positive 5, I still get positive 25. But if I take a cube of a number, it's possible for me to get negative numbers, right? So if this is even, we have absolute values. If it's odd, we don't have absolute values.
So that's only a variable.
Right, it's only for variables. Because if you take the absolute value of 5, what do you get? 5. So you just simplify it. Let's do this one. Is there a number out there that we could take times itself 5 times to get to negative 32? No. Are you sure? Negative 2, right? So I have the 5th root of negative 2 to the 5th power. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. Now, f to the 6th, how do I break that up? And g to the 5th is just g to the 5th. And h squared, there's no way for me to break that up. We don't need absolute values because we have an odd root. So 5th root of negative 2 to the 5th is just negative 2. 5th root of f to the 5th is f. This f is going to stay inside the root. Fifth root of g, the fifth is g. And we have an h squared left. So I take the fifth root of f times h squared. And I want to look at one more, and it's off your, it's the second problem on your introduction pack. We're going to take a look at a problem like this. Before I solve this, I'm going to rewrite it in a different way. I'm going to rewrite it as negative 7 minus 2 times x, 7 plus 2 times x. How would you do that problem? If I got rid of the radicals and I put in x's, how would you do that? What's that process called? Well, we have two processes that we could use, but how would you do it? Elizabeth? You can FOIL it or use a distribution property. It's up to you. So if I FOIL, 7 times 7 is 49. Outside, 7 times 2x is 14x. Inside, we get negative 14x. And last terms, I would get negative 4x squared. Right? We understand that, yes? So we're just FOILing. So we're going to use this same philosophy for this problem. Okay, so if I FOIL this problem up here, first term, 7 times 7 is 49. Outsides. On the outside, I have 7 and I have 2 root 6. So I have 7 times 2 root 6. Yeah, it's going to give me 14 root 6. So I multiply the coefficients together. 7 times 2 is 14. So plus 14. And I multiply the radical parts together. Well, there's just a root 6. It's kind of like 1 times x is just x. So we just have root 6. On the insides, I have negative 2 root 6 times 7 gives me negative 14 root 6. And then we have our last terms. Our last terms are, well, we have negative 2 root 6 times positive 2 root 6. So if we multiply the coefficients together, negative 2 times 2 is negative 4. What's root 6 times root 6?
Oh, root 36.
Okay, so root 36, which is what? Which is just 6. Root 6 times root 6 is the same thing as root 6 squared. What happens to a square root and a squared? Yeah, it's just they cancel each other out. We're left with 6. So here we have negative 4. Negative 2 times 2 is negative 4. Times the square root of 6 times square root of 6 is just 6. Okay, now we combine like terms. Well, I'm going to multiply these together. So I have 49 plus 14 root 6 minus 14 root 6 minus 24. 49 minus 24 is 25. And then 14 root 6 minus 14 root 6 is 0. They cancel each other out. So we're left with 25.